Okay, so here's another video on some optimization problems. So in this case, Sam's sweatshirt shop sells 6 CW sweatshirts. Sam knows that if he prices shirts at $30 each, then he will sell 102 of them each month. So in that case, the revenue would just be 30 times 102. Right? You find revenue by how much the shirts sell for, by how many of them that you sold, right? But then we have this little information here that says he also knows that for each $2 increase in price, he will sell 3 fewer sweatshirts. So let's see if we can write an equation out of that. We're going to define a variable x as the number of $2 increments. Okay. So if I put 1 in for x, that means I've increased the price by $2. Okay, so that means that if I have a $2 increment, one $2 increment, I would have 30 plus 2x. And then the revenue, 102, would actually, I'm sorry, the number of shirts sold is going to drop by 3, so I put a minus 3x there. So that would be my revenue equation based on, again, x is the number of $2 increments in price. Okay, so we take that and multiply it out. Let's see, that would be 3060. Multiply 30 by that. And then multiply this times that and this times that. That'd be negative 90 and 204. So that'd be plus 114x. And then minus 6x squared. So that's my revenue equation. I want to maximize that. So I would divide. Take the derivative. So r prime is equal to 114 minus 12x. Set that equals 0, and we get 12x is equal to 114, or x is equal to 114 divided by 12, 9.5. X equals 9.5. Now remember that x was $2 increments, so that would be 9.5 $2 increments. So that would be like adding $19. So 30 plus 19, so the sell price, that would be priced at $49. So if it's priced at $49, we would be selling 9.5 times 3. Yeah, that's not really possible. So I guess it'd have to be either 9 or 10. So if we did 10, that would actually be $50. And that would be selling 30 less of those, so that would be 72. Wait, what was it? 3,600. And what was this one? That was 330. Yeah, interesting. Okay. What would 49 be? Or 48 would be minus 18. The 48 times, add 3 more to that, 75. That's 48 times 75. Ah, it's the same. Yeah. So those would be the two prices. Okay, now the sweatshirt costs Sam $20 each. Find the price to maximize his profit. So that means profit is equal to revenue minus cost. So that means that the profit would be equal to this minus 20. So that would be 30, or 3040 plus 114x minus 6x squared. So notice when we take the derivative here, we get the same thing, don't we? So it wouldn't change the, oh, what am I doing? That was embarrassing. Okay, forget what I just said. The cost would be actually $20 times the number of things. So this would be 3060 plus 114x minus 6x squared minus $20 times the number of t-shirts, which would be 102 minus 3x. So that is going to be different. P equals 3060 plus 114x minus 6x squared minus 2040 plus 60x. So if we combine all that, we get, so 3060 minus 2040 would be 1020. And if we add 60x to that, that'd be 174x. And that would be minus 6x squared. So this time when we take the derivative, we get p prime is equal to 174 minus 12x. Set that equals 0. And this time we're dividing 12 into 174. So we go 174 divided by 12 equals, 14.5. So x equals 14.5, which again is, x is the number of $2 increments. So we want to go with either 14 or 15. If we do 14, that would mean my sweatshirt is priced at $44. If I do 15, it would be priced at $45. So 49 or 50 would give me the max, 49 or 48 would give me the maximum, no, 48 or 50 would give me the maximum, yeah, I messed up on those. So x is the number of $2 increments, so 14, that'd be 28, yeah. So 30 plus 28 would be $58. Or if I did 15, that'd be 30, so 30 plus 30 would be $60. So the two prices here would be 58 and 60. The two prices without the cost was 48 and 50. Okay. Jan and Jim Jingle Bells sells beautiful bells at $3 each, and each bell costs them $1.20 a piece. So using a similar logic as to what we did up here, we wrote a revenue equation and a profit equation. So it's entirely possible these two claims could be right. It says Jan claims that if they decrease the price, then they would increase the revenue. However, Jim claims that if they increase the price, they would decrease, or they would increase their profit. Who is correct? Well, if you increase your revenue, then you also are going to increase your profit. So to just find out if they're correct or not, we'd have to take the derivative and see if it's, we'd have to take the derivative and find out where it's positive or negative. So this would be, so you just take the derivative of this and then find out whether it's positive to the right of 0. Because if x is 0, that means you'd leave it at this price. So we would just want to take the derivative and check it to the right of 0 and to the left of 0 to find out whether it's increasing or not, and then do the same thing to this one. Okay. Let me go back and do another one of these. Farmer Jones changed her mind again. She now wants to build 4 pig pens in 1x4 in a 1x4 rectangular grid. No barn this time. If she has 250 feet of fencing available, find the dimensions that would maximize the area. So 1x4 rectangular grid, that means it's like this. So no barns, so we need fencing around the whole thing. So we have 200 meter fencing, so let's do some labeling here. If that's X, that means all of these things are X, and then we'll call this whole thing Y. That way we know that the area is X times Y. And that's what we want to do, is maximize that, but that's not a nice, neat equation because it's got too many variables in it. So I need to adjust them. So instead of Y, I'm going to write Y as 250 minus 1, 2, 3, 4, 5, 5x, but then we got to divide that by 2 because there's 2 y's there. So in other words, I'm taking 250 at the beginning, taking off the 5x's, and then what's left is going to be split between the 2 y's. So that's why I divide by 2. So over here, I'm going to go A equals X times 125 minus 2.5x. So area is equal to 125x minus 2.5x squared. Take the derivative, and I get A prime is equal to 125 minus 5x. So that equals 0. We get 5x is equal to 125, which means x is equal to 25. And remember, x is the length of this side piece of fencing. And I can put 25 in here, which would be, whoops. Yeah, I could put 25 in there, which would be 125. 250 minus 125 would be 125. And divide that in 2. And I get 62.5. So the dimensions would be 25 by 62.5. That would be the dimensions of the biggest pig pen he can make. This one's very similar, but the idea is you got a barn there. So sides, she has 8. Oh, so it's just a rectangular pig pen. So the barn doesn't need fencing. So if that's X and that's X, then this is just 180 minus 2X. I have to divide by 2 because there's not 2 sides to it. So then you would just go area is equal to X times that. So that'd be 180X minus 2X squared. A prime would be 180 minus 4X is equal to 0. So 4X is equal to 180, which means X is equal to 45. So my pin would be 45 by 90. Optimization.